Good evening, everyone. It is with great pleasure to welcome you all to this exciting and insightful webinar organized by the IEEE Power and Energy Society Student Branch Chapter of University of Jaffna. My name is Vishwamagamage, and I'm truly honored to be your host for this event. Today, we have gathered to explore a topic that resonates deeply with students, educators, and professionals alike. From theory to practice, bridging the gap between academic and industry in power and energy. As we all know, the transition from classroom learning to real world application is often one of the most challenging and crucial phases in an engineer's journey. This evening, we are fortunate to hear from someone who has not only made that leap but also has excelled in it. Please join me in welcoming our distinguished speaker, Mr. Shaib Ibrahim. He is a senior electrical engineer at Acciona Energia USA Global and brings over a decade of rich professional experience in both thermal and renewable energy. Currently, he plays a pivotal role in the development of large-scale solar, wind, and battery energy storage power across North America. Mr. Ibrahim holds a bachelor's degree in electrical and electronic engineering and a master's in sustainable energy. We are truly honored to have him here today, sharing his journey, insights, and advice on how we too can bridge the gap between academia and industry. So, without further delay, let's dive into today's session. Once again, welcome. Thank you for joining. Yes, sir, you can take over.
So much. Thank you so much for this introduction. I do appreciate the invitation to present on this important topic. So I will share my screen and discuss whatever we have today. I hope this section is going to be a lively one. And then I'm also glad to hear from all people across different countries. Even though this program is put together by University of Jaffna, IEEE, the Power and Energy Society, but we have other people who are joining from different countries and schools as well. So without further ado, I'll share my screen and then we can continue from there. Okay. Just a second. So can you all see my screen? If someone can see my screen, let me know. Can you all see my screen now?
Yes, sir.
Okay, good. Okay, so I will start this presentation with a bit of story about myself and what has motivated me throughout my career and what I have been trying to do, share the same journey with other young professionals that I feel like is going to be very helpful to them because a lot has changed throughout the past 10 years when I started. So 11 years ago when I started my career, I actually failed to ask the right questions and I failed to, just a moment, I think I lost my screen. Sorry. Okay. Correct. So I failed to ask the right questions, and I also failed to take inventory of my skills, and I failed to take charge of my career. I left everything in the hands of other people to decide. And the unfortunate happened when I was among a group of other young engineers that were laid off. And up to today, if you ask me the reason why we were laid off, I do not have the reason because we were never told. And that has been a great lesson for me. Nobody wants to be laid off, but I would say the unfortunate happened. It is actually a blessing in disguise. At the end of it all, even though there were some failures in the beginning, but I have tried to change a lot of things. And looking back, I've always thought that missing that opportunity to stay and work was actually a good thing. At the same time, I was lucky to find a great mentor, Graham, who taught me a lot of things and actually ignited the desire of power and the energy industry into me. So I'm deeply grateful to my first mentor. And I'll jump on straight to the presentation for today. So in today's presentation, we are going to talk about the relationship between the theory, whatever we have been studying in the school, and how we relate that to the industry. This program, as I mentioned, is put together by the students in University of Jaffna Batu. I'm glad to hear that other people from different places have also joined. In the introduction, I have been introduced, so I will not talk much about myself. So even though I put a slide here to talk a bit about myself, when I started my career in 2014, I started with a power distribution company and then moved into thermal power generation. And then I moved into renewables after I graduated from my master program. I also volunteer as it was said in the introduction. So I'll just move on to the next. This is a bit about my education and the lances and certifications that I hold. EIT is actually Engineer in Training lances. It is the first lances that you would get if you want to progress to have a professional engineer lances in the US. Even though I have gone through all, I'm just left with approval for the professional lances. Also have a PMP, and then NAPSEP. NAPSEP actually means North American Board of Certified Energy Practitioners. So this is for only solar, those who are into solar. And then LEED Green Associates is Leadership in Energy and Environmental Design. Okay, now let's come back to the main reason why we are here for the presentation. This presentation is going to be very interactive. I'm going to give the opportunity for you to ask questions. I'm not going to be the only one to talk, so we can all have enough from this webinar. The student life, we are involved in endless assignments, research, and then this also gives us the opportunity to meet new people on campus and establish some friendship. It is also a time when we start taking some interviews, preparing ourselves for internships and then full-time jobs opportunities. But there's always a time when this phase of our life will come to an end, and then we transition into the graduation phase. And this phase, we are very happy. Whoever is graduating has a lot of expectations on them, their personal expectations as well as expectations from families and friends. And a lot of people will be looking up to you. So this is the happy moment. You're stepping out of school, no more assignments, We are happy that we are going to start a career. We are going to start making some money. We will start making some family and have a good life. This is the kind of picture we have in our mind and the immediate sense of freedom. So we have some joy, hope, and the belief and the promise of a good future. Then at this phase, when we are very happy about graduation and having those expectations, we need to sit down and ask ourselves some detailed questions. Okay, so that takes us to our next. I would want you to take if you have a phone, take your phone and let's have some interaction here. You are going to scan a QR code, and once you scan the QR code, you answer some few questions. This is not engineering question, it's just a basic question, so do not worry. Okay, so this is the first question here. This is 20 seconds, so you need to be very fast. Kindly scan this QR code and respond to this question. I guess I have to also do same. Just feel free to type in whatever you are thinking of. Yeah, just feel free to type. Okay, great. So we are having some great answers here. And then the most outstanding one is people are thinking about finding a job. So job stand out for us. So we'll go to the next question. Next question will be this one. So let's go with this one too. Okay, people are typing soft skills, communication, mental balance. Communication, okay, networking, soft skills, problem solving, handling different people. Okay. Okay. Entrepreneurship, communication, experiences and coding. Okay, balancing life, problem solving. So we have the most outstanding ones: soft skills, networking, communication. Okay, these are important things. Okay, let's go to the last question, and then last question: which industry do you intend to work in after graduation? After graduating, yeah. Academia and research, clean energy, oil company, waste. Power, energy. Okay, let's get more answers for this. Thermal power plants, manufacturing and processing, okay. Automation, electronics and research. Okay, tech field, telecommunication, power, automotive, thermal power plants. Okay. Power, okay, thermal power plants. Okay, so we have some good answers here. Power, okay, tech field. Okay, so good. These are good questions. Thank you so much for taking these questions, and I do appreciate your response. Okay, let's go to the next one. Okay, so thank you for answering the question. If you realize most of the answers that you provided to the first one, I have been talking to students and early career professionals. I have been mentoring other students, and they all have similar aspirations and similar expectations. So if you look at this pie chart here, we have like 59% and then 40% professionals and students. And this, if you look at them, most of the questions I do ask them is mentorship, career guidance, research collaboration, and then I can also enter. Most people do seek for career guidance. So in career guidance, people want to know the industries they can work in, the opportunities out there after school. And so you could see that the answers you provided actually correlate with this. Most of you are talking about having a job. That is the biggest concern that you have. And it is the same thing that applies to people across the world, in the US, in Canada, in Africa, in Asia. All the people I have been talking to, they have similar concern. So that is just a good exercise. Okay, now what are some of the challenges if you are in school or if you are in the early part of your career? Most people do lack the direction. They do have limited experience. They are very unassured of the job market. Depending on the country you are, if you are in the US, the job market could be different. If you are in Sri Lanka, it could as well be different. But most people are very unassured whether they would actually land a job after school. So this is a challenge. And then there is also a gap between having somebody to actually show you the direction. That is mentorship. So what mentorship does is that somebody have gone through some experience and some pain for a number of years, let's say 5 years. And then what mentorship does is that instead of you also going through similar problem or challenges, you would have somebody to actually guide you and direct you to do the right things. As you have seen in the previous slides, the answer to the questions that you provided actually match with the interactions I've been having with other people. And also hard to connect, it's very hard to connect theory and practice. What we actually learn in school and what we do on the field, there's some kind of difference, but how do you relate that? Immediately you graduate and then you are handed an opportunity, let's say as an electrical engineer, working in renewable energy, let's say solar industry. What are some of the skills you need that you can carry along? Everything that you learn in school will not be very important in the job. It depends on where you work. So if somebody works in telecommunication, probably the power system courses that you have taken might not be very, very important there. Even though it was very, very good you took the course, but it might not be applicable. And then there's also a vast amount of uncertainty among students and early career professionals. So these are some of the challenges everyone faces, irrespective of where they are, whether they are in Asia or America or Africa, wherever they are, the problems are the same. Jobs in Sri Lanka. Even though this webinar is meant for students in Sri Lanka, but looking at it, securing a job may be difficult irrespective of where you are. And this is very common in most places around the world, even though there could be some differences. Some countries, it's easy to find a job. Some countries, it may be very hard to do it. My Zoom actually crashed, so I'm restarting this wherever I left. Sorry for that. Okay, sorry for that. Can you hear me?
Yes, sir.
Okay, sorry.
Yes, sir.
Yeah, sorry. I got a break in my Zoom, so sorry. Okay, so I was talking about the jobs in Sri Lanka and the opportunities there. This applies to everywhere. So we need the right mindset, we need the right approach, and there will always be job everywhere you go. There will always be job, but it is always available for those who are ready and those who are prepared to take up those opportunities. And how do we frame our mindset to prepare for the industry? Okay, so this is the beginning of a lasting career growth. The right mindset and the right tools. We intend to actually not have a job but have a career. There's a difference between a job and a career. A job is something you do for a very short period of time. But so if you are doing an internship could actually be a job. It's not something you are going to do for a very long time. But career is something you do for a very long period of time and build some experience and skills in that same area. And all this begins from, oh, this thing crashing again. Sharing back my screen. So, hope this time I don't have that problem. Okay. So I hope this time I won't have this problem. I have to use my multiple screen. Okay, so we need to prepare our CV, get someone to review it for us. And we need to practice interview questions and have stories to share with measurable impact. I have been reviewing other people's resume, and most of the times what you do find is that people try to write generic job description without impact. So you need to have someone who has experience and knowledge about resumes, how to stand out of the crowd. Your CV has to be optimized for the specific job that you are applying for. And you do not have to use the same CV across every job that you have seen online. If you have a job, let's say electrical design engineer, you have to look at the requirements and then match your experience with what they are asking for. If you do that, then you have a chance of being called for an interview. You need to also network as much as possible. I was glad to hear some of you mention in the responses that you provided networking. Networking is very important in our industry. And one thing I'll tell you about networking is that I have experienced this. The first job I got when I was in the US is through a network, someone I know. And the person was contacted for a job. The person was already having his job, and then he sent me the job that can I take a look if I'm interested. So I got my first job through someone I know. And so network is very important. You need to also seek for help when the need arises. Do not try to solve all your problems alone. Try to seek help whenever you think somebody has a better chance of giving you a very good idea. And you have to also attend conferences, especially IEEE conferences and SIGRE or PMI, Project Management Institute conferences, if you can. So framing your mindset and having the tools available is part of the step that you have to establish once you are in school, and then even when you are about graduating, or even when you are in your early part of your career, you need to have the right mindset and the tools. The tools are both technical tools and then the people in your network. These are all things that help us. Let's talk about opportunities and then the industry. One thing about the electrical engineering field is that electrical engineering is in almost everything, whether it is in energy, power, or every industry has some aspect of it that demands or that needs energy. And so if you pursue electrical engineering, I see that you have actually done something that is across every industry. If you are an electrical engineering student, some of the opportunities out there could be an electrical design engineer, a protection and control engineer, automation engineer, substation engineer. You could be an interconnection engineer, studies engineer. So this is power system studies. And then energy planner. You could as well be a field service engineer, or you could be a consultant. You can become a lot of things, but these are the list of things I put together. For industries, you can go into renewables, and these renewables could include either the solar industry or wind, hydro, geothermal. Some companies could focus on only solar, or other companies could have multiple of renewables. So when I started working in the US, the first company I worked for only focused on solar and battery energy storage. And then, but right now, where I work, we are involved in multiple renewable projects, wind and other biomass. Yeah. Okay. And others could also go into conventional power generation, where you have natural gas-fired power plant, a coal plant, nuclear, or oil. So when we say power plant, usually it is named. The power plant is actually named based on the source of the source of generation. So the input, if it is a natural gas-fired, then we call natural gas-fired power plant. But this, if it is coal, it could also be coal power plant, nuclear, or oil. So whatever is the driving input is what we name it. So it's the same thing that applies to renewables. If we are using solar, which is the sunlight, we say solar power plant because the sunlight is the main source. Okay, you know all of this in your theory, but let's continue. In communication, others could decide to go into telecom, data centers, energy infrastructures, and power plants. In power plants, remember, we do not have only electrical engineers doing only power stuff, but you have to also think about communication. So if you have, let's say you have the transformer, you have the circuit breakers, you have the disconnect switches, you have a lot of equipment in the power plant. All these power plants, we need to gather information from them, and this information has to be transmitted. So that's where communication comes in. You have to transmit all these signals to a localized or a central point where the status or the operational status of the plant or the substation is monitored. So communication also applies here. That is why in school we take courses in digital system communication and analog signals. So you could see the relationship here. Whatever you study in school, it is not the end, but in practicality, you would see that in the industry. And the only difference is that in the industry, you are dealing with the real world situation. But in school, we only learn the theory where we are not using specific projects. So for instance, you can model a power plant. Let me use this one. You can model a power plant, let's say a solar power plant in MATLAB. MATLAB is the software that gives you the platform to model this. But you are not actually modeling a plant that is going to be built in Sri Lanka. That one is done by the engineers on the field. They will model it or using other software. It could be MATLAB or ETAB or other software. So there's a relationship. Whatever we learn in school is actually amplified on a larger scale in the industry. Okay, electrical engineers also, we have opportunities in the industry, manufacturing. Manufacturing of electrical equipment like circuit breakers. So you would see this, those who go into the OEMs like Siemens, Schneider Electric, ABB, Hitachi. These companies manufacture huge electrical equipment, transformers that are costing millions of dollars to build. And we have the automobile industry. Some people also mention automobile. They want to go into automobile, food processing, beverages, electronics and semiconductors, chemicals and pharmaceuticals. And then aerospace. Who doesn't want to go into aerospace? So even though aerospace engineering is a separate thing, but they also need electrical engineers to work in the facility. Okay, let's talk about oil and gas. Somebody mentioned they want to work in Kuwait's oil and gas industry. That's great to know. So in oil and gas, electrical engineers have opportunities. No machines could work without electricity. So far as I know, every machine will need power to work, even medical devices. And I'm glad to actually have a friend of mine who is a medical doctor who is on this webinar. He's also interested in electrical engineering. So he joined us in this webinar. Thank you, Doc, for coming. So in oil and gas, we have others who go into drilling and production, gas processing, oil refineries. In substation and utilities, we have other engineers who would only work in the utilities. So when I talk about utilities could be like the power distribution companies that are actually distributing electricity to customers, to hospitals, banks, schools, and factories. So that level is distribution. They usually will supply this electricity at a lower voltage. And then you have transmission, others who also go into transmission. Transmission is actually the infrastructure that takes the electricity from power plant. So if you produce a power at the generation facility, the voltage at the generation station is usually lower. But in order to transmit to longer distances across countries and regions, you need to actually step up the voltage to a higher voltage. And as such, you need a transmission infrastructure. And we all have seen these huge transmission towers across the cities. When you drive, you see all these big transmission towers taking the power from the substation, the generation substation, all along. And then that is also being stepped down to a lower level before it is distributed to customers. So if you are an electrical engineer, you can as well go into distribution that is focused on supplying power to customers, or go into transmission that is also involved in taking power from generation, or you can go into generation that actually produces the power itself. And then the other sectors I mentioned. So there is abundant opportunity, but the problem is, how do you help yourself by placing yourself into any of these industries? You need to take inventory of your skills. I'll come back to that level. You need to actually know who you are. Okay. Next. So this, you see a substation that looks very nice. I will not play this video. I'll continue to the next slide. And technical skills. We as engineers need to know what skills are important, or what are the tools that are important and will make a difference. Remember, when you are graduating and looking for a job, why are you looking for a job? For us, we may be thinking we need a job in order to make money. We need to make money to survive. But remember, the companies do not, that is not their main concern. Every company is employing you to come and solve a problem. Every company is employing you to come and help the company to grow. So that is the mindset you need. You need to have the mindset of what can I do to help the company to progress, and not necessarily the money. So in my interaction with other students across different places, different countries, some of them will say they need money, but it is not about the money. You need to think about what you can do. So here I just put together some technical skills that you need. It all depends on the industry. Some industry may require you to have some skills, other industries may not. So this is not an exhaustive list. I just put this together just to demonstrate to you that you may need an AutoCAD, especially in the early part of your career. You need to know how to draw electrical single lines. You need to know how to draw layouts. And other industries, you may need to know how to use ETAB. And ETAB is a power system software. I'm sure some of you know about ETAB. We have PSCAD, PSSCE, we have TARA, and then protection softwares like QuickSet, as a related QuickSet. And that is actually for XEL. You need to also know some automation tools. So automation tools, you might be, let's say, RTAX, real-time automation controllers. Some other softwares are Neplan, MATLAB, Sign, PowerWorld, Aspen, Dixie Silence, WinIGS, SKM Power Tools. And then as well, you might also want to know some standards that are in the industry. These standards are actually what guide most of the industries in practice actually depend on industry standard. So what industry standard does is that it gives you an established minimum requirement for doing some engineering in practice, so that you don't have every country doing something different. We want to have a standard where people who are in Europe, if Europeans are dependent on the IEC standard, what is done in France could actually be done. Let's say the same can be applied in Germany or Sri Lanka or China. And then IEEE applies almost every country or jurisdiction. So these are some of the technical skills you need to know. And the next one is the most important, which we engineers usually do not pay attention to, is the soft skills. And I was very happy to see most of you answered the question by saying soft skills. Remember, I always say this: the technical skills will get you into the job, but what will actually keep you in the job and what will actually make you progress in the job is your soft skills. You need to learn how to communicate effectively in your team. So it's not only communication, but effective communication. For instance, if you are working in a group and your teammate wants something from you, they send you a message or a Teams chat. How do you respond to that? Do you wait and respond the following day, or do you respond at any time that you want? So you need to know, okay, do you have to be very responsive and respond to the person and not wait over 24 hours and keeping the person in suspense? If you don't communicate effectively, your team may not be happy, and that is very dangerous. Active listening, problem solving. I mentioned earlier on, no company is employing you to come in and just sit in the office and do nothing. They are actually employing you to solve their problem. So you actually get paid for solving problems. And so the more you solve difficult problems, then that is where you make more money. Your income will never be more than the type of problems that you solve. So if you are only solving simple problems, then you get a lower pay. If you solve difficult problems, then you get higher pay. So problem solving is one of the skills that we need to actually learn as engineers. We need to learn to be a team player, be able to work with people in your group. You need to learn how to resolve conflict when there's a problem. How do you resolve that conflict? If you have disagreement with your teammates say, let's do A, you want us to do B. You need to know how to resolve that conflict of listening to the other person and then understanding their concern, whatever they're saying, then before you can actually bring your input. And then try to come to a common solution. And the common solution is a common goal that is in line with the company or your project targets. So everything has to go in line. You need to learn how to deal with hard conversations. So hard conversations, if you disagree with somebody, how do you it also relates to conflict resolution. You need to have emotional intelligence. So there's emotional intelligence, there's artificial intelligence. And we engineers, normally, as I mentioned, we care so much about technical stuff. They are all good, but emotional intelligence is also how you deal with people. Remember, human beings, we are the most difficult and complex to deal with. We are very difficult people. It's easier to operate a machine. You just press something or type in start, it start. If you say stop, the machine will stop. But human beings are not like that. We also need to learn organization. So organization is a very key skill. You may have, let's say, 5 projects in a week, but how do you organize yourself to prioritize which one is more important, and the ones that are not very urgent and important, you can delegate it to someone else. And even the way you arrange your your stuff, your project folders, or how you arrange your document also is helpful. It's just like when you pick your cloth, you know where to put your shoe, you know where to put your cloth. You know where to, if you have children, you know where to put your children's cloth. You don't just mix everything up. So organization is also very important. You want to go into a company with a very organized mindset. If you are having softwares, you put all software, let's say all power system softwares in one folder. And in each of the folders, you categorize them. If you have drawing stuff, that's AutoCAD or other drawing stuff, you put them in a separate folder. That's organization. We also need to focus on taking initiatives. So taking initiative actually is one of the most important things. You don't want your boss or people to be telling you to do everything. You want to be in a position that you can actually start something and then communicate that to your boss that this is what you are doing. You need to initiate something different, right? You need to be innovative, bring new ideas without necessarily being told to do things. So in short, technical skills are important, and then soft skills are super important. Okay, so here we have the theory and then practice. I did mention this earlier on. In school, I just put this basic formula here just to explain. We learn a whole lot of formulas, everything about power, voltage, current, resistance, circuit theory, and all those things. How are they actually applicable in the industry? In reality, they are applicable. As at now, even if you work in the industry for 30 years, you will still use the theory that you studied in school. All the formulas, we use that in calculating load flow, short circuit analysis, and arc flash studies. They are all applicable in the industry. So don't leave anything. If you don't have to memorize them, you just need to know that this formula is here and the formula is applicable to solve this particular problem. And you would actually enjoy it when you start working, because in school everything is just writing and learning to write an exam. But in the industry, you are not actually learning to write an exam. You are actually practicing to solve problems. If there's less demand, let's say we take the customers the electrical users are the demand, and then the power generation is the supply. If there's less demand on generation, right, what will happen is that then you have the generation. If you're using synchronous generators, the power plant machines will begin to run very fast because the frequency will go up higher than the nominal. If you are in Sri Lanka, I'm sure you are using 50 hertz. So 50 hertz system, if frequency is higher, it means that we have less demand. Less people are using electricity at that time. So the machines will begin to run faster. What do you do to mitigate that problem? But beyond some level, you have the generator to trip. Because if it runs faster, what happens is that the generators will begin to vibrate. And with vibrations, you can break some mechanical parts. So you will learn this in school: frequency, demand, generation and supply, power generation and supply and demand. Under normal circumstances, generation should be equal to demand. But this is not going to be the situation. There's always some kind of variation. People are always switching off and switching on their power supply. Factories may be working on high or low. So because of that, there will be some kind of variations. And this is where you actually apply. Most of them in the industry, you don't sit down to write or calculate on a paper. It has actually been replicated in a software or a program. But you need to know how to use the software. You need to know how to use the software. But if you don't have the theory, then it becomes difficult to use the software. So there's a relationship between theory and practice. Whatever we learn is actually applicable on a different level and on a practical level, which is the reality. Okay, now how do we bridge the gap between theory, right, between school and then the industry? First of all, I mentioned earlier on, you need to be very intentional. When I started, I mentioned some of the failures I did in my career. When I started, I was not writing anything down. I was not taking inventory of my skills. I was not intentional. I left my career for other people to decide for me. So leaving your career for other people to decide is a dangerous thing. And you don't want to leave anything for somebody to decide. Somebody will have a decision to make about your career. But what I'm talking about here is that you need to actually have a plan how you want to develop yourself. You need to write your plan down. In the next 2 years, where do you want to see yourself? In the next 5 years, where do you want to see yourself? And how much salary you want to actually make. And I have done this. Once I learned and I knew about this, I have actually put this into practice. Whatever I wrote down, that in this time, I want to get to this level, I want to get this salary. Exactly the same thing happened. It just worked to me like as if it's magic. And so I know that thing really works. You need to be intentional. You need to design your career by breaking it down into pieces. It can be 2 years or 5 years and 10 years, 15 years. What do you want to do? How much money do you want to make? Write it down. Once you write it down, your mind will now force you. Your mind will now conscientize you to work on that. You need to identify your interest. Do you want to go into oil and gas or manufacturing, or you want to go into power companies, or you want to go into telecommunication? Whatever you want to do, you need to actually have that interest. And you need to write your skills. As I mentioned, take inventory of your skills. Even as at me, I always I have set an alarm every Friday, every weekend. I need to actually write my skills down. What am I good at? What am I lacking? I write it down and I try to close the gap by taking what? If I find some gap, then I try to take some training. You can pay for your own training or recommend to your boss or your supervisor that I think I need to take this training to help me to perform better in my work. So take inventory of your skills, write it down and identify the gaps. When you are a student and about to graduate, you need to take internships. Even before graduation, you need to take internships. This is actually the start where you begin to have some interest in the industry. Take training and certifications to narrow the gap. And also, you need to look out for people who can help you, like mentors, to actually coach you on some things, some mistakes they did, right? And then how they have overcome it, so that you do not make the same mistakes. And also try to join industry organization like IEEE or SIGRE. There are a lot of organizations you could join, but in power or in electrical engineering, IEEE and SIGRE are the topmost. SIGRE focuses on power systems, and then IEEE focuses on almost everything: telecommunication, medical devices, and power, electronics. So IEEE is like a big umbrella. SIGRE is also there. All these groups I am a member of them, and I do contribute to volunteering. Yes. Okay, so in summary, I would want to keep this brief so that you will have the opportunity to ask questions and then make this section more interactive. Summary: it is not too late to start anything. You can always fix anything, especially for you people. If you are still in school, or you are still in the early part of your career, let's say less than 5 years, you can almost fix everything. Even if you are beyond 10 years or 15 years in your career, you can almost fix anything. You need to stay curious and ask questions. When you start your career, that time nobody has higher expectations on you. That is the time you ask all the questions. There is no stupid question. Every question is important. And once your team knows that you are still fresh, you do not have a lot of industry experience, you can ask anything and they will answer you and help you. You need to discover yourself. This also relates to actually writing down things. Do not trust your memory that you can remember. Write everything. And then whatever you decide to do, try to find your true purpose. If you find your true purpose in something, then that gives you actually the energy to keep going. Okay, let's go the last slide. The last slide is thank you for attending, and then special thanks to the organizers, especially Himal, who put all these things together with his organizers. Okay, now is question and answers time.
Hello, sir.
Yeah, sorry, my computer worried me today, but feel free to ask questions. One last thing about me during my free time. What do I do in my free time? I do volunteer. I love to watch comedy, network with like-minded, and then I create content on my blog, which is Shailearning.com. The QR code is at the top. You can reach out to me through my blog or LinkedIn. Okay, so let's go by question and answers.
Hello, sir.
Hello.
Hello. Sir, first of all, I'm very thankful to you to arrange this kind of workshop for us. I have a request for you to arrange another workshop on PLC and SCADA.
Oh, can you say that again? What is the question? Can you repeat your question? Can you hear me?
Sir, I have no question, but I have a request for you to arrange a new seminar or webinar for us on PLC and SCADA.
Oh, okay. So we can talk about that later on. So you want us to have like another webinar? Okay. So we can discuss that later on, right? Okay. So what questions again? feel free to ask questions, and yeah, feel free to ask questions now.
Yes, sir.
Yes. You can also type your questions in the chat. I can
My name is Mr.
Yeah.
Yes. My name is Dija from Tanzania. Yeah, first of all, I would like to thank you for this kind of presentation. So it really helpful for us. Yeah, my question is, I'm doing this electrical designing, so I just get difficult for the software to start the software. Have a lot of software like AutoCAD. So I confuse which one I can take for the electrical design. You mentioned here AutoCAD, but also I saw another software like ePlan. So yeah. I want to know, because before I was always I'm using AutoCAD, but also I find another software ePlan. So I want to know more about this ePlan, and then if have any, we can see we have many software. So which one is the best one? So as I can choose maybe 2 or 3, so I can go with the software. So that is my question. Thank you very much.
Okay, thank you for your question. So it all depends on what you actually want to achieve with the software. AutoCAD, if you want to do electrical drawings, you mentioned ePlan. Yes, you can use ePlan to do electrical drawings. And then you can use AutoCAD also to do drawings. And even in AutoCAD, you have AutoCAD electrical. That is actually electrical specific. So any one of them will work for you.
Okay, thank you very much. Thank you.
Okay, any other question? Let's have more questions. Okay, someone asked a question.
Good day.
Okay.
Yeah, I want to ask. Good day, Mr. Shaibu. My name is Victor, and still a student at Pan Atlantic University here in Nigeria. And I'm currently in my 400 level. And so I just want to ask little questions, because you talked about how we can find our purpose and other different things as well. But as a student, we are being exposed to different courses and maybe internships as well, being exposed to different fields in electrical engineering. How do we now tend to know which one exactly can we pick out from this whole thing? How do we decide which one to go into? So as a student, I'm skeptical in it. So that's why I try to listen and follow up in what you said. Thank you.
Okay, thank you so much. I think that's a very good question. This is very, very important question. Myself, when I was in undergrad, we learn a lot of subjects, a lot of courses, and sometimes you are overwhelmed with the number of programs you take. But at the end of the day, not all the courses will be important, right? The only problem here is that as a student, you are still not very sure of the industry you want to work in, especially if you are not in a country that has a lot of job opportunities. So you cannot be very selective. It is always good to learn everything that is at your disposal. And once you are about to graduate or you have taken some internships, the internships are actually the first steps. If you do an internship in oil and gas, it's most likely you will begin to see, okay, in oil and gas, this is what is there. Let's say if you work in telecommunication, now you begin to understand the importance of your work, and you might develop interest to continue in telecommunication or switch to power industry. And even with power, where do you want to work? You want to work in distribution, transmission, or generation. These are different things altogether, even though all of them, you use the same substation, different substation at different voltage levels. So what I would say is that at this time, you don't have a lot of choices. You just have to learn everything, and then try to have your own interest. What do you want to do? What you want to do will direct you. So if you don't want to go to oil and gas, and I see oil and gas job, I don't apply. I will only focus on, let's say, power generation. That is where I'll look at. And even with power generation, you need to look at the number of jobs in power generation. Most power plants will have more jobs at construction phase. And once the plant is built, and we would have the contractors, everybody will leave the site, and we will now have operational team. So operational team, normally in control room, you have few number of people running shifts. I have worked in control room. In the control room, we were only like 4 people who will come on the shift and will be in the control room. And then we have mechanical team. The mechanical team usually will be comprised of large numbers because they will always be on the field doing some mechanical work, and so they need more hands. So you need to know the industry you want, but at this time, do not try to take everything. That's what I would say. Just try to take everything, but try to narrow down yourself by writing what you like, and try to look at the skills that are important in that industry, and then push yourself towards that. I hope that helps.
Yes, thank you so much, Mr. Shelby. Thank you.
Okay, another question again. Okay, somebody asked from Ghana, Kinsley from Ghana says that some books on studying electrical software like ETAB and that. Okay, so most of this software, electrical and AutoCAD, right? If you need some books about them, there are free resources. And especially if you're a student, you can always go on the website of ETAB, and you will find that ETAB has student version. You can actually apply for student version, put in your credential, they'll give you a student software version, and you can use that one to practice. And in the software, you can always download, you can always have access to the manual, and that applies to most of these softwares. I have written a blog on my website that I have listed some number of softwares that you can have free, and some other softwares that are proprietary you actually have to pay for. And so that's what I'll say about that. Okay. Is there any other person who wants to ask a question? Just feel free to ask. Okay, somebody talked about a request to have another workshop on artificial intelligence, PLC, which is programmable logic controllers, and SCADA, supervisory control in data acquisition. So this, we can talk about this. You can contact me, Rahman. You can contact me and we can discuss this later on.
Yes, sir.
Okay, somebody asked about the PowerPoint, if I can share this PowerPoint notes. So yeah, I can share these PowerPoint notes, but I will need your email addresses, or you can reach out to me on my blog, and then yeah, I can send them to you. Okay, somebody asked a question. I don't know if this is a question. Marvin is asking about, you are currently working on renewables, and would you know? I can't see this one. Okay, will you know if only high voltage or also low voltage levels? I would like to know. So yeah, so renewables, whether renewable or conventional power generation, for instance, let's use solar power plant. So if you have solar power plant, you have the PV modules, right? These PV modules will produce DC power. And then the DC voltage that will come, you need an inverter. Most of the inverters will be, you could either use a string inverter or a central inverter. So a string inverter is usually the smaller size inverters. And then the central inverter is actually a bigger inverter. So it depends on the size of the project. If you are building a large renewable energy project and then you are using an inverter, the inverter converts the DC to AC, correct? The input to the inverter is a DC, let's say 1500 volts is the DC side. And then the AC side, you would have, let's say, 600 volts. This 600 volts is very small. You cannot transmit it, the power to long distances using 600 volts. So now the inverter will be connected to a transformer. You have 600 volts transformed to, let's say, a medium voltage, which is, let's say, for instance, 34,500 volts. This 34,500 volts will also need to be stepped up to, let's say, a transmission level voltage. And so voltage levels, both low voltage and medium and high voltage levels, are applicable in renewables. But it all depends on the size of the project and the customers you are actually feeding. If you are connecting to the utility voltage must be matched. So it comes from low voltage, let's say 600 volts, 34,500 volts, which is medium voltage. Then that is also step up in the substation to, let's say, 161,000 volts, 161 kV, or it can be 345,000 volts. It can be any voltage depending on the grade. I hope that answers that. So somebody also asked about, please, is the blog you are linking, you're talking about? Yeah, so Shailearning.com is my blog post. You can reach me there. I support students there by reviewing their CVs free for them. I also have section one-on-one where we interact and see how we can help. Yeah, and I also have some technical posts there on engineering stuff there. Yeah. Any other question? Let's make it more interactive. So maybe we can wrap up in the next 10-15 minutes. So let's get your questions. Okay, I'm just going back a bit. So if anyone has a question, maybe you see something you want to ask, but you can ask them, we can wrap it up.
Yes, you hear me?
Okay, can you ask a question?
Yes. My question is, I have a background in chemical engineering, but recently I've just learned sustainable energy engineering. So the reason why I'm trying to raise this question is the question is about how can I link up the electrical background, because I'm facing a problem link up the electrical background.
You are breaking out. I cannot hear you well. Yeah, you are breaking. Can you ask your question again? Can you ask your question again? Okay, I think somebody has a question. What's your name? Livingston. Can you ask your question? Yeah, Livingston.
Yes, my question is, I have a background in chemical engineering, but recently I've just learned sustainable energy engineering. So the reason why I'm trying to raise this question is because I'm facing a problem link up the electrical background.
Okay, I think somebody has a question.
Actually, I'm saying I think chemical engineering in the bachelor's level, but I've just enrolled for the same body.
I cannot hear you. Are not
Let me just write my question on the chat.
I did not hear your question. Can you repeat it? Or maybe type. Can you type your question? Type your question. Yes, can you type your question, Livingston? Okay, I'll be wrapping up the talk in the next 5 minutes. If you have a question, ask within the next 5 minutes. So I'll be wrapping up, and then I'll allow the organizers to take over and then close the program. Somebody asking a question, how we can incorporate AI to smart grid, and also what the future of cybersecurity is in power grid. So all these are very important topics: artificial intelligence, and then into smart grid, cybersecurity into the power grid. They are all very important. And artificial intelligence in power system did not start recently. If you look at some studies, for a long time, several years ago, even 1953, AI application in power system was started around that time, and a lot has been done. So using artificial intelligence in power grid is not something that is very, very new, but there's always going to be improvement in how things are done, how we actually monitor the power grid and take proactive steps. So that is where now efficiency in artificial intelligence will play a key role. How we respond to incidents, how we are able to forecast problems before they happen. In the application of renewables, we will be able to gather a lot of data and information and interpretation about the weather, how weather pattern looks like, let's say in different countries or regions. And based on that knowledge, we'll be able to actually forecast how much power we should get from renewables. Something like that, AI will be very important. Cybersecurity is important in every infrastructure. So you do not want people to hack into the power grid and shut power plants down. So cybersecurity also is a very, very important area. I think other people have questions. David, what is the best advice you give to an undergraduate electrical engineering student who wants to go into graduate studies after school? Can we transition right after school, or rather get some experience before going into graduate studies? Okay, this is also an important question. It all depends on the plan you have for yourself. As I mentioned, you need to take charge of your career. You need to actually write what you want to do. You can either get industry experience before you go to academics again, or some people will decide to just jump into academics after undergrad. They just go to graduate studies, finish it up, and then come to industry. It all depends on individual. For me, I went into industry, got some experience, and then came to academics, and then got back to industry. And who knows, maybe I'll go back to academics or whatever, but it all depends on individual levels. And that is where, if you have a mentor, it also makes a difference. I remember when I was trying to make a decision to travel to the US for my studies, I have a mentor. I went to him at that time. He advised me to take the best decision, and I have not regretted it. He advised me. So you need to talk to people who have some understanding about the pros and cons, some decisions you have to take. If you are a single person, it's easy. If you are married, it's difficult because now you have to seek your spouse. Your spouse has to agree to some things. So it all depends on which level you are. And somebody asked a question about how to handle different personalities in workplace, working environment. Okay, that is one of the skill you need to develop. It's a soft skill you need to develop, how to deal with people. But dealing with people is very difficult. However, if you learn how to deal with people, you need to listen to people if there is a disagreement. You are not trying to make the other person feel like the person is wrong and you are right. If you go that approach, everybody will become defensive. So in the workplace, when you are dealing with different personalities, I think active listening helps because everybody will want to be listened to. And once they are listened to, try to not argue or try to not put them like they are wrong. And when you go that approach, I think you can deal with any other person. And sometimes maybe the person has done something good at workplace, try to acknowledge that they have done something good. Once you acknowledge that, thank you for taking up this responsibility and doing this, I really appreciate your work. Once you talk like that to anybody, and now even later on you are trying to disagree a bit, the person might not be, the person might listen. So that's what you have to do. Somebody is asking a question, Livingston is asking somebody in chemical engineering. Okay, I think somebody in chemical engineering wants to get into sustainable energy engineering. How difficult is it for the person to cope up with the electrical energy system? Okay, so sustainable energy, when you talk about sustainable energy, it is not actually, I did masters in sustainable energy. So you are not looking at sustainable energy as if it is purely electrical engineering. So you would learn a lot of things into like leadership. You will learn a lot of things about technology. You learn something about management. You learn about renewable energy sources. And so we have people from different engineering field, from mechanical. I have some of my classmates from mechanical, some of them from different engineering courses. So it's something that can be done. Livingston. Okay, I think if there's no any other question, I'll hand over to the organizer of the program, and then we can bring a close to it. Okay, but finally, thank you so much for attending this program. I do appreciate your time, and I hope it helps, and I hope we do connect some other time. Okay, so University of Jaffna, the organizer, can you take over, and then let's bring a close to this.
Okay, sir. Thank you so much, sir. On behalf of the IEEE Power and Energy Society Student Branch Chapter of the University of Jaffna, I would like to extend our heartfelt gratitude to our guest speaker, Engineer Shaibu Ibrahim, for sharing his time, insights, and expertise with us today. As a small token of appreciation, we are pleased to present you with a token of appreciation from our society. Recognize your contribution and presence here today. We are deeply honored to have you as our guest and hope this marks the beginning of a continued connection. Thank you so much. Thank you so much, sir. So next, I call upon Ms. S. Nitushika, the advisor of IEEE Power and Energy Society Student Branch Chapter of University of Jaffna, to deliver the thank you speech.
Hello everyone. As we wrap up our webinar titled From Theory to Practice, Bridging the Gap Between Academia and Industry in Power and Energy, I want to take a moment to thank all of you for joining us today. A special thanks to our esteemed speaker, Mr. Shaibu Ibrahim, a senior electrical engineer at Acciona Energy USA Global. Your insights into the practical application of theoretical concepts in the power and energy sector have been truly enlightening, and your experience in both thermal and renewable energy is truly inspiring, sir. Thank you so much for sharing your knowledge with us. And I also want to thank the IEEE PES Student Committee for organizing this event and ensuring its success. So your hard work and dedication to connecting students with industry professionals like so is greatly appreciated. Thank you to all our participants for your engagement and questions. We hope you've found this session informative and motivating as you prepare for your future careers. Let's continue to work together to bridge the gap between academia and industry. Thank you once again. I look forward to seeing you at our future events. Thank you. Thank you.
Bye-bye, and have a good rest of the time.
Dear participants, please check the chat for the certificate of participation, and you can fill that within the next 5